Okay, so welcome intellectuals to Siding Institute. So in our today's lesson, we are going to focus on integration. Since we've just done differentiation, so it's not going to be a very big deal for us to understand integration. So just a quick introduction that I can give you is that integration is just the opposite of differentiation. That's why it's sometimes called anti-differentiation. So just the opposite of what we are doing is what you'll be doing. Okay, so looking at the question that I have here, I've got about 10 questions which came in the last academic year exam. And you are going to see that these questions carried about almost 40 marks. So that makes it very important for you to focus on integration too much as you are preparing for mathematics. The reason being that during exams, or I may say during tests, you for both test 1 and test 2, you are not assessed on integration because it is the last topic. So you expect a lot of questions to come during an exam. So that's why I'm going to first focus on integration. Then after that, we'll be preparing again with these other courses. So it's very important for you guys who are not registered with our tuitions to register now, because this is the only lesson that you are going to access for free. But this other lesson, starting from where we started in all the courses, will only be accessed by those who are going to register. So without wasting much of our time, let's take a look on the first question that we have here. So evaluating the integral, we have been given 2 in x over x. Then we are asked to integrate to find the value using the limits that you have been given here. When you have these numbers, these are just limits that you have been given, which are the value of x. The value which is on top is the upper variable of x, and the one on the lower is the lower variable. That means it is usually the lesser number. So what you are going to do here, when you have been given the question like this, for us to integrate, we are going to use U-substitution. Okay, it is the method that we are going to be using in most of the questions, but there are some of the questions that U-substitution can't be used. Hence, we are going to apply other concepts like integration by parts. So what you are going to do here, we are going to find the value of u. When you look at 2 ln x over x, you can see that we have two functions here. We have 2 ln x. If I have to forget about the constant, because whenever we are integrating, we ignore the constant. Okay, so we have two functions here. We have the first function is ln x, and the other function is the one in the denominator, which is just x. So which one can we use as x so that we can just be able to differentiate it, then we integrate it very easily. So we don't need to choose by randomly or by favoring one function in preference to others. So what we need to do, we need to follow the rule which we use, which we call LIAT. These are just letters, these are initials, but you can remember maybe by calling it light. So L here stand for logarithm, then I stand for inverse trigonometry. So inverse trig functions. So if you have something like sine inverse of x, cos inverse of x, arcsine, arctan, those you need to choose it first. Okay, then here is for algebra, all the functions that are going to be in the form of algebra. For example, this x is in the form of algebra. Then when you look at ln x is in the form of logarithm. So you need to say that anything that is in the form of logarithm, the chances of choosing it first in preference to the other is high. Okay, then t is just for trigonometric function. or trig functions, then the last which we go for is an exponential function. So you need to understand this. Exponential functions, and I'm sure this is going to make a lot of sense as we be solving more questions, because as for now it may look so confusing. So looking at the function that we have in x and we have x. This is in form of logarithm and this is an algebra. So which is coming first here? You can see that L is coming first than A. So we are going to use U to be in x, not x. So we are going to say U is going to be equal to in x. After that, now we are going to differentiate U, which we are going to call du, differentiate U in terms of x, that is the x, du dx, because most of you used to get confused whenever I say du dx. It just means differentiate U in terms of x. So the derivative of in x, we all know by now that is just 1 over x. Okay. After that, now the next thing that we are going to do, we are going to make du the subject of the formula, or dx. Let's just be making dx the subject of the formula. So if you have to cross multiply here, we are going to say that dx is going to be multiplied by 1, and you are going to have dx is going to be equal, then this x is going to be multiplied by du, then we are going to have x du. Okay, so now with that in our mind, we can go now and replace the given values. So I may recommend first you integrate, then you focus on the variables that we have there. So let's just focus on integrating 2 in x over x. Okay, so you are going to appreciate that what we are going to have here, we know that this in x is just the value for u. So where there is in x, we are going to put u. So we are going to have 2, instead of writing in x, we are going to have 2u. Then we say over x. Then where there is dx, we are going to put x du, because dx is equal to x du. So we say the integral of x du. You can see that x and x are going to cancel. Then our integral becomes 2u du. So this makes a lot of sense. Whenever you are using U substitution, make sure you remain with only U in the expression, because you can't integrate more than one variable. Okay, if we have x and y, if x is not cancelling, just know that U substitution has failed. So with this information in our mind, we can differentiate now that. So what are we going to do? We are going to just say, when we were differentiation, we used to multiply 1 to the power, then we subtract. We used to multiply, if you have, for example, 2x squared, we used to multiply this to this, we have 4, then we subtract 1 to the power, we used to have 4x. But here is just the opposite. We are going to be add 1 to the power, then we divide by the power, by the new power. So what you are going to do, you are going to say, you are going to have 2u. Since this u has got any number, any variable, or I may say any number has just a silent power of 1. So this u has got a power of 1, so we need to add another 1. Then we divide by the new power here, which is 1 plus 1. Okay, so with that in our mind, we are going to say our integral is going to become 2u squared over 2, of which this and this are going to cancel. That means our integral just become u squared. But we need to remember that they are asking us to evaluate, hence we need to include these these variables that we have there. So now the most key point here, which you shouldn't miss, is that if you have used U substitution, that means to say you even need to convert, Okay, you need to convert the limits. You have to change the limits which were in terms of x now in terms of u. So in this case we have u which is equal to in x from our initial assumption which we made. Then we are going to say if we use now 1, we replace where there is x, what will be the value of 1? So we say for x is equal to 1, u is equal to ln, where there is x we put 1, and this is just going to give us 0. So that now is now going to become our upper value is going to be 0. Let's now look at the lower value. So for x is equal to the natural log u there, the value of u is going to be equal to the same in x. Now where there is x we replace by e, and we know that in e is just 1. So with that in our mind, we are going now to just get done with this integral. We can just simplify that. So we have 0, we have 1, then we have u squared. So this can be written now as u squared, then 0, then 1. So what we are going to do, we are going to say, we are going to replace where there is u, we are going to put 0. Okay, so we are going to put 0. Where there is u there, we put 0. We say 0 squared. Then we are going to subtract the same way that we did with 0, we do with 1. Now we subtract. So where there is u, we are going to put 1. We squared it since u is squared. Then you are going to have the answer which is going here is going to give us 0, and here is just going to give us 1. So our answer is just negative 1. And here you can see that we don't have the answer, but actually the answer is supposed to be negative 1. Here there was just a typo and it was corrected. So this is supposed to be the correct answer. So that's what you basically need to know about differentiation. It's just the opposite of integration is just the opposite of differentiation. And always whenever you are using U-substitution, remember the initials, light for L to stand for logarithm, inverse trig functions, algebra, trig function, then E for exponential functions. After that, another emphasis, whenever you are using U-substitution, don't forget to change the limits. The assumption that you made that u is equal to in x, now replace the value of x by the values that you have there, so that you may have the new values for you, since the derivative that we have at the end is not in terms of x like we used to see here, it is in terms of u, so we need new values. So that's the only concept that you need to get. And with the next question, I'll try to be a little bit faster, since you've gotten most of the important concept that you need to know. So we have now this question here, question 10. Evaluate the value of the integral of x sine x dx. Okay, so in this case, what we need to know first, we are going to forget first about these values. We want to try if U-substitution is going to help us. Okay, so from U-substitution, you have the integral of x sine x. So the function that we have here, we have x and sine x. Which one can we use as u? So just use, you write light, and you can see that we have algebra here and we have trig. Algebra is coming before trig, so we go for algebra. So what you are going to say, we are going to let u to be equal to x. That means du dx, the derivative of this u is just going to be equal to 1. Then we can make dx the subject of the formula. If you have to cross multiply, you're just going to get dx to be equal to du. So replacing now in the integral that we have, we are going to have to say the integral now is now going to become, where there is x we put u, then sine x, and where the dx we are going to put du, since dx is equal to du. We are going to do this. So from this you can tell that there is no way we can cancel this x. and we have also U. So this can't work. That means U substitution can't work. So if U substitution fails, you go for another method, which we are calling integration by parts. Okay, so this is the other method that we are going to use to differentiate this function which U substitution has failed us. So you have the function, shouldn't forget, we have the function x sine x dx. We are looking for the integral. So according to differentiation by parts, or integration by parts, so we are going to say that the derivative, this is the formula that you need to know by heart. The derivative, the integral of u dv is equal to u multiplied by v minus the integral of v du. This is the formula that you need to know. Now, the first important thing, we need to identify the value of u, the value of v, what is dv, and what is du. This is the next thing now which we are going to use. From light, the same light that we are using, we said u is x, and that remains true. So u is x. If this is u, this u stands for x. That means the remaining part is dv here. So that means this is our dv. So you say dv is equal to sine x here, sine x dx. And this makes a lot of sense because this is what we are looking for. We have u and we have dv. This is u and dv. So now, in the formula, we need to have u. Yes, we have it. We need to have v. How do we get v? We are going to get v from dv. Okay? And this is found by just integrating this part. Because mathematically, we are going to introduce. Okay? Let me write here to make it more clear. So we say sine x dx. So we're going to introduce the integral here. You also introduce the integral here. So now the thing that you need to remember here is that the integral of dx is just x. Okay? So the same applies, the integral of dv is just v. So you say v is equal to the integral of sine x dx. What is the integral of sine x? Okay, from what we started from on differentiation, we learned to say that the derivative of sine x was positive cosine x. Okay, and the derivative for cos x was negative sine x. Now, because integration is just the opposite, that means sine x will now be giving us negative cos x, and cos x will be giving us the positive of sine x when we are integrating, which is just the opposite of differentiation from what we learned. So after that, what we are going to do next, since we have v and we have dv and we have u, so we can just come and replace all the values that we have. So we have u is x, and we have dv is sine x dx. And you can see that this is, we are just rewriting this question that we are looking for. After that, you can see u is equal to x, so you say x, then v is equal to negative cos x. So negative cos x, we are subtracting by the integral of v here. The integral of v is negative cos x, so you say negative cos x. Then what is du? Okay, so we have to find du. Okay, so now here is what we are going to do. we have u, so we are going to find du dx. Okay, so I'm going to say, I can use this simple part. I'm going to say, since we have u which is equal to x, then du dx is just the derivative of x, which is just 1. We can cross multiply, it's just 1 over 1. We can cross multiply. You're going to find that dx is going to be equal to du. That means to say, whenever you've seen du there, replace dx. So I'm going to put here we had v, which is just this one, and where there is du, we are putting dx. The reason we are doing that, we want the letters to be matching, because we can't have x here and have du here. That is not going to make sense. Okay, so after that, you can see that this is just the question that we are looking for, so we can focus on this part, or maybe we go by writing. So you can multiply out this one, you're going to get the answer. It's just going to be equal to negative x cos x, because we have a negative there, and we have this negative and this negative are going to give us positive, so we're going to have positive the integral of cos x, then dx. Okay, you can go ahead and say x sine x dx is going to be equal to negative x cos x. We just write the integral of cos x. The derivative of cos x was negative sine x. Now the integral is going to be the opposite. Instead of us having the negative, we're going to be having the positive. So you are going to have positive sine x, that is the integral of cosine x. So you're going to say positive, you're going to have positive sine x. So this is how far now which we have, but let's remember that we have these values of x, which are the limits that we need to have. Here we didn't use U-substitution. U-substitution failed us, so no need to change the limits. We are just going to take them like the way they are. So we are going to say to now, since we have found the derivative of this, to now include now the effect of pi there to the power pi and 0 there. So we have pi and we have 0 of this. So we are just going to write this as, you say, negative x cosine x plus sine x. Then you say this should be pi and 0. So how do we do this? Just the same way. So we're going to start by replacing x everywhere. Where there is x, we put pi. So we're going to say negative pi, then cosine. Where there is x, we put pi, plus sine. Where there is x, we put pi. Then now we are subtracting by this one with 0. So it's a negative. Where there is x here, we put 0. So I'm going to have negative 0 cosine 0 plus sine, here you have 0. Okay, so you can now just simplify this. Negative pi cos pi, when you convert it into Lagrange, just give us 180. By now this. So it's more like they are saying cos 180 is just negative 9. Cos 180 is just negative 1 according to special angles. So we're going to have, where there is cos pi, we're going to replace with negative 1. So we have negative pi there, then multiply by negative 1, then plus sine pi is more like sine 180, which is just 0. Okay, that is just 0. Sine 180 is 0. You just have to take note of that. So we are adding plus 0 there. Then we are subtracting. 0 multiplied by this is just going to give us 0, and sine 0 is just 0. So it's more like we are just looking with the value, which is negative pi multiplied by negative 1, which is just going to give us pi. And going back to check for our answer, I'm going to see that we have our answer, which is correct there, which is just B. So that's how we go about these questions. So integration is very interesting. You just need to abide to the principles that are behind solving any kind of question that you are going to meet. So after that, we have now this question. Okay, we have now this question, which is question 14. Which of the following answers equal to the integral? So we are looking for the answer which is equal to the integral of 1 over 7x plus e to the power pi. So looking at this, in the bracket we have two functions. Okay, the first function is we can let the first function to be a, which is just 1 over 7x, and the other function to be b, which is just e to the power pi. So if you are differentiating, you are integrating two functions, we just use the simple formula or the identity. So you say the integral, this is not even an identity, just a rule. So if you are integrating two functions a plus b, it's just the same that you can just integrate separately. You can separate a dx plus the integral of b dx. Okay, so that means to say this is now going to be written as the integral. We separate this 1 over 7x, you say dx, then plus also the integral of e to the power pi, then dx. So I'm going to start with this one. Okay, so we need to just understand that the integral, let me even write it here in a box so that you'll be able to remember. The integral of k dx is just going to be equal to k, where k is a constant. If k is constant, the integral of that is just going to be equal to the same constant now multiplied by x. Okay, so what we are going to do in this case, we are going to factor out 1 over 7 in this, because this 1 over 7x can also be written as 1 over 7 then 1 over x, because when we multiply out this, we are just going to go back to this. So it's nice, we can even write it like this, just one and the same. So I'm going to write like this. I'm going to say 1 over 7, I'm going to put it outside the integral, then I'm going to say the integral of 1 over x, because 1 over 7 is just the constant, then dx. Then when you look at this, e to the power pi, okay, the integral of e to the power pi, e to the power pi is just a constant. It's different from e to the power x, okay, because x becomes a variable, but pi is just a number which we already know. Okay, it can be 180 in two largest, or it can be 3.142 if you are using a calculator. That is the constant. These are numbers. So if this is a constant, e to the power pi is a constant. That means the derivative of this is just going to be equal to e to the power pi. Then you multiply it by x, because I said that whenever you are integrating a constant, you say a constant multiplied by x, so I'm multiplying it by x, so I can put x here. So whenever you are integrating, for us to know that you are integrating, you have to put it to some constant. Okay, so you are going by saying, what is now the integral of 1 over x? Okay, so if I have to recall, we used to say that the dy dx of 1 over x is used to give us ln x. Now, because integration is the opposite, okay, integration is the opposite, that means the integral, okay, let me do this, it's supposed to be this, so we say the dy dx over ln x used to give us 1 over x. That means the integral of 1 over x now is going to be equal to ln x, because this is just the opposite. So you say the integral of this is just going to give us ln x. So whenever you see 1 over x, they're asking for the integral, just say ln x. Then you have x e to the power x plus c. So multiplying 1 multiplied by ln x, you have ln x over 7, then plus x e to the power, this is not x but pi, and plus c. So you can even look for the answer that we have, the answer which looks like this, and it is no other than c. So c is our answer there. So integration is very simple, just need to be smart. So we have another question. The area of the region bounded by x is equal to 1, y is equal to 2, and x is equal to negative 1, and y is equal to 3x squared plus 4 is given by. So yeah, we need to find the area. This is application of integration, so we can apply integration in finding the area. So the area bounded by the curve, so we need to understand that the value of x, these are just values. X, the bigger one, is just the upper variable, and the smaller one here is the lower variable. So our main work here, these are the same values which you used to see. For example, the bigger one is on top and the smaller one is below there. So the only consideration that we need to have here is on the value of the function. So we have two functions. We have y is equal to 2 and we have y is equal to 3x squared plus 4. So what you need to understand here, if you have been given two functions, you have f of x and g of x. From the fact that if f of x is greater than g of x, the area is going to be equal to the integral of f of x minus g of x. Okay, that's how you find the area. But if g of x is the one which is greater than f of x, that means the integral is the area is just going to be equal to, just the same way we just change. We are going to start now with g of x minus f of x. So now looking at this, we want to see which one is bigger between this one and this one, so that we may find the area by subtracting the smaller one from the bigger one. So we are going to say y we already have is 2. So for us to estimate if this one is bigger, we are going to put any number, because we have the number which is running, the values of x are running from from 1 all the way to negative 1. So we can put any number. It can be 1 or negative 1, because these two values are included. That's why they are bounded by that curve. Okay, so for us to estimate, we can take any number. We can either take negative 1 or 1. As we can see that if we square this 3, let me use negative 1, 3 negative 1 squared plus 4, we are going to get a number, because this will give us positive 1 multiplied by this 3 plus this 7. Even if we use positive 1, we still are going to have 7. So we're going to say that this is greater than this one. Hence the area is going to be equal to the integral of this is going to be the first one to write 3x squared plus 4 Now we subtract the smaller one, which is 2. Always test to see which one is greater. Don't just look, because sometimes they may trick you. Okay, so after that you can just simplify now, because we know that we have right terms there, like 4 minus 2 can give us 2, so we're going to have 3x squared minus 2, then gx. So from that now we can find our area, which is just going to be equal to our area. You know, we have to put b here and a, where b is just the bigger variable, which is just 1. So I'm going to put 1 here and negative 1 here for 3x squared minus 2, then gx. That means to say we just have to start by integrating. How do we integrating? We add the 1 to the power, then we divide by the new power. So we say, how can we integrate 3x squared? We just add 1 here. We are going to have 3x to the power 3, then divide by the new power, which is just 3. Then minus, how do we integrate a constant? Any constant is integrated by just adding x to it. Okay, that's why I was saying that when you're integrating k, we just say k multiplied by x. So I'm going to have 2x there. But let's not forget that these are bounded in the x-axis by 1, the negative 1. So we can deal with this. Here, you know, 3 and 3 can go into this, so our expression remains to be x to the power 3 minus 2x. Then you have 1, then negative 1. So let's try to simplify that now. We see if we are going to get it right. So we have minus 2x, then we have 1, then negative 1. So what can we do? We are going to say we start with the upper variable. So we say 1 to the power 3 minus 2. Then where there is x, we put 1. Then we subtract by the next variable, which is x now, to the power negative 1 to the power 3 minus 2, then negative 1. Then we simplify. You're going to have 1. This is going to give us negative 2. Minus negative 1 to the power 3 will always give us a negative. So we're going to have negative 1. And this are going to give us a positive. So we're going to have positive 2. So you can see that here we're going to have negative 1. Then minus, here we're going to have positive 1. So it's negative 1. We're going to have positive 1, of course. Let me see something here. So we need to have negative 1 here, then minus 1. Okay, first let me try to go back to the question. So after we had 1 here, we have 3x to the power 3, then over 3. Okay, so we are saying minus to understand where this became a minus. So we're supposed to have a positive, because 4 minus 2 supposed to give us positive 2, not minus 2. So we're supposed to have positive 2 there. So positive 2x, positive 2x. So this is where the mistake is. So we're supposed to have positive here, and supposed to have so the expression remains to be x to the power 3, now positive 2x. So now we can simplify, then 1, negative 1. So we can just replace now the values. So if you have to put 1 here, we start with 1, you're going to have 1 to the power 3 is just 1. Then 2 here, we put 1, you're going to have positive 2. Okay. Then we subtract by the one with the negative. So putting a negative there, we're going to have negative 1. Then putting a negative there, we're going to have negative 2. Because negative multiplied by 2, we're going to have negative 2. So we're going to have our answer here to be 3. The negative, what is in the brackets there is negative 3. So I have 3 and positive 3 here, because negative and negative is going to give us positive 3. Then we're going to add, we're going to get 6 as our answer. So looking at the option that we have been given, you can see that G is the correct answer there. So this question, you have already even been told to say that you can use substitution method or any other method which is just you are okay with it. So to find the value of that integral, which is just e to the power, so we need to find, I'm going to forget about this. So I'll say the integral of e to the power sine x, then we have cosine x, then dx. Okay, so we have this sine x and sine x, or adjust a trig. So using light, it can just confuse us. So what you do, if you have both a trig, for you to choose the value of u, just use the one from the function which is complicated. So we have this is more complicated than cos x. So we say the value of x is going to be sine x. Don't take the or expression here. So say just say the value of u is going to be sine x. That means du dx is going to be the derivative of sine x, which is just cosine x. Okay, so how can we make now dx the subject of the formula? We can cross multiply here. You're going to say that you're going to have dx, then cosine x, if you have to multiply, then it's going to be equal to x du. You can divide by cos x everywhere, by cos x everywhere. So our dx is going to be equal to x du over cosine x. That's how you actually found it. Okay, that's how you get. In fact, do we need to have here x? We just needed to have 1, not x. So there is no need for this x. So it is du over cos x. Okay, because our integral was just cos x, I'm supposed to just write 1 cos x minus over 1. So after that, so we have our dx to be du over cos x. So we can go and replace here. So I'm going to say e, where there is sine x, you put u, because sine x is equal to u. Then you say cosine x. But dx is given by du over cos x, of which cos x and cos x can cancel. That means e to the power u becomes just du there. And this makes a lot of sense with u substitution, because we only have one variable which is just u. How can we integrate e to the power u? Okay, how can we integrate that? So you can see that the integral, you need to remember that the integral, I mentioned this, of e to the power x is just e to the power x. The reason is just very simple. Okay, the reason is just very simple. Whenever you are integrating, you can multiply this by x, and you divide by x, you still get to the same value. So that's just the fact here. So even here, the integral of e to the power u is just going to be equal to e to the power u. But what we need to remember, with u substitution, we need to change the limits that we have been given. Okay, before we apply the units, we need to change them. If you go direct, you get the wrong answer. Okay, you almost get this one. So what you need to do, you are going to say you've already made an assumption to say that u is equal to sine x. So what is going to be the value of u when x is equal to pi? This one. So when x is equal to pi, the value of u is going to be equal to sine pi, which I say that pi is just 180, so it's sine 180. It is just going to be equal to 0. What happens now when x is equal to 0? What will be the value of u? It says sine 0 degrees is just 0. So in this case, they are just telling us to say that now deal with this e to the power u. Now put the limits 0 and 0. So if you have to say, they are telling us to say that e to the power 0 minus e to the power 0, which just give us 0. So the answer here is D. Okay, so now let's try to test one of the question which looks to be more complicated, but very simple. If you can just remember a few concepts which we learned earlier. So this question is integration using partial fractions. So we are asked to express first the partial fraction of this expression, and after that we need to evaluate this integral. So what we are going to do here, we have been given to say 5x minus 4 over 2x squared plus x minus 1. So the first thing that you can just do here, we need to actually factorize this. This is that can be factorized, and it's no longer my work to teach you how to factorize. So you say plus x minus 1. So you can say the product is this multiplied by this is negative 2, and the sum is the coefficient of x, which is just 1. So what is going to be the factors? Those two numbers that we can add to have 1, and we multiply to have negative 2 is just 2 and negative 1. Okay, so use this now to factor out this. You are going to get 5x minus 4 is going to be equal to 2x minus 1. Those are the steps that I've skipped, plus 1, which you just need to do it. So when you look now at this, how can we break them into partial fraction? 5x minus 4 over 2x minus 1, then x plus 1. These are just, we have to, so we have to, the denominator is made, is a product of two functions. So we just need to break this into two partial fractions. So we are going to have a over this, so it is 2x minus 1, then plus b over x plus 1, this one. So what can we do next? We are going to multiply now everything by the denominator. So we are going to multiply this by the denominator, which is 2x minus 1, then x plus 1, this 2x plus 1, then x plus 1, then this 2x plus 1, then x plus 1. You multiply everything. So you are going to say that if you have to multiply this and this are going to cancel, are going to remain with 5x minus 4, then this and this are going to cancel. We are going to remain with a multiplied by this, which you can even factor out. A multiplied by x, we are going to have ax, then a multiplied by 1, we are going to have just a. Then you can see that this and this are going to cancel. We've remained with this, so b multiplied by 2x, you are going to have 2bx. Then b multiplied by 1, you are going to get b. So what you do, you start by correcting those that have x. We have ax, then we have 2bx. X is common, so we can cancel it out. That means our first equation becomes 5 is equal to a plus 2b. This is our equation 1. How can we find our equation 2? We are going to take now constants. We have negative 4, The other constant that we have, which doesn't have a variable, is a, and the other one is b, so it's plus b there. That's our equation 2. So it's very simple for us to actually find the value for a or b. So what we can do here, we can just make a the subject of the formula or b the subject of the formula. So what we are going to do here, we are going to say here we have, this is negative 2, it's not positive, so this is negative, this is negative 1. So we're supposed to have negative here, and we're supposed to have negative here. So if you have to expand that, you're going to have negative here, because b minus this, you just give us this, then multiply by negative 1, it's supposed to give us negative b. So it's supposed to have negative b here. So I want to use this to make b the subject of the formula. What are we going to do? We are going to say, we can take negative b to the other side, it's going to be positive, and we've remained with a, and this can go to the other side, it's going to be positive 4. This is going to be our equation 3. Okay, so we're going to put this equation 3 into this expression. Let's just use this one. So we're going to say 5 is equal to a plus 2 multiplied by b, but our value of b is a plus 4. So we're going to have 5 is equal to a, 2 multiplied by this is 2a, then 2 multiplied by 4 is 8. Taking it to the other side, it's going to be 5 minus 8, then this is going to give us 3a. So 3a is just going to give us 5 minus 8 is just negative 3 divided by 3 divided by 3. Our a is going to be equal to negative 1. But we can recall that b is equal to a plus 4. So I have to put negative 1 here, which is the value of x. We're going to find that negative 1 plus 4, our b is just going to be equal to 3. So the partial fraction which we made is now going to become, so we're going to say the partial fraction for 5x minus 4 is going to be, where here we had 2x squared, then plus x minus 1, is just going to be equal to, we had a here, and we had b there. So our a is going to be negative 1 over 2x plus 1. It's actually 2x minus 1, not 2x plus 1. It's 2x minus 1. This is the same mistake which we even made. You don't need to repeat it. 2x minus 1. So it's 2x minus 1. Then we are adding by the value of b, which was 3. Then over, we add x plus 1 in the denominator. X plus 1. So that's how you write this into partial fraction. This question had 8 marks. If you go through past papers, you're going to confirm that. So after that, now we need now to find the integral. This one, we need to find the integral of 5x minus 4 over 2x squared plus x minus 1. We need to find the integral, which is just very simple, because when you look at this, it's just the same as this. So it is okay for us to actually say this can also be written as, we can replace where there is this, we put the partial fractions which we actually found. So we're going to say our partial fraction are going to be negative 1 over 2x minus 1, then plus 3, then x plus 1 there, then gx. From what I told you, you can remember that I said if you are integrating two functions a plus b, it's just the same with we can integrate just by separating. So we're going to separate that. We're going to find the integral specifically for -1, then 2x minus 1 dx. Then we are going to add by the integral of 3 over x plus 1. So finding the integrals are just one and the same way. So I'm going to use the other page, which is likely to be the last one. So you're going to say we are looking first for the integral of -1 over 2x minus 1. So you can let u to be 2x minus 1. That means how can we differentiate u? We said u dx is going to be equal to the derivative of 2x is just 2. Then you can appreciate that we can make now dx the subject of the formula. So making dx the subject of the formula, this multiplied by this, we are going to have 2 dx, then du. You can divide by 2, you can divide by 2. That means this and this are going to, this and this are going to cancel. So that means dx is going to be equal to du over 2. Okay, now replace. Okay, let's replace. What do we have? We have -1. Then we have here, we are going to say u because it is just equal to that. Then while there is dx, we are going to put du over 2. This of course can be simplified because we are going to we can put our 2 here, we can multiply this, we're going to have 2u. Okay, multiply by that. Then after that you can factor out, because negative half can be factored out. We don't need a constant, so we're going to remain with 1 over u, because if you have to multiply this and this, you still get back to this. Then we have du. What do we know about the derivative of 1 over x? Is just in x. That means even the derivative of the integration or the integral of 1 over u is just going to be equal to ln u. So you say ln u. But we need to remember that u, so you just have to include that but to gain a lot of marks. U is equal to 2x minus 1. So I'm going to say the answer is going to be equal to -half, then ln 2x minus 1. Then, we never ended from there. We had also another integral, which was actually 3, then x plus 1. We need to integrate that. So 3x plus 1, then dx. What do we need to know? We say x is equal to u is equal to that, then du dx is going to be equal to 1. Du dx is just the derivative of this, just 1, this is 0. We can make dx the subject of the formula, so this multiplied by this, so dx is just going to be equal to du. So with that now we can just replace 3 over, while there is x plus 1 we put just u, then while there is dx we put du, because dx is equal to du, so you say du. Same applies to what we did. We don't need this 3, so you can take it out. You are going to remain with 1 over u, because if you have to multiply this and this, we still get back to this, so we don't change anything. Then du. The same integral which we had here. So you can say that we are going to have the integral of 1 over u is just ln u. But in this case, our u is equal to x plus 1. So we're going to get 3 ln, where now there is u, say x plus 1. If you are that student who like recording things, you can remember that if you have a, ln x is just the same as ln x raised to the power this a. So you can maybe write it as ln x plus 1 raised to the power 3, and this can also be written as ln 2x minus 1 raised to the power negative half, if you want to further your answering. But since we were just adding here, so our final answer is going to be this ln 2x minus 1 raised to the power negative half, then plus this, which is ln x plus 1 raised to the power 3. So that's how you find the integral. That's how you can get the 8 marks. So 8 marks for partial fractions, which we did in semester 1, and 4 marks for integrating. So we can now do the last question. I think we have to do the last question. So this question also just came to section B, and it has also 8 marks. If it's not 8 marks, I'm sure it's supposed to be maybe 7 marks. It can't go less than that. It should be within that range. So we need to integrate that, and because these guys are very much okay, they want you to pass. They even tell you to say that let you to be what? Let you to be 4 minus cos squared x. So what you can write for you to make the differentiation to be very simple, you're going to say 4. This can also be written as cos x now squared because of this. So how can we find du dx? The derivative of a constant is just 0. So now this part we use chain rule. So chain rule will tell us to multiply this by this. You're going to have negative 2. Then we subtract 1 to this. You're going to have now this cos x. We have subtracted already 1, so it has to be remaining with 1, so we can't even put 1 here. It will have no any meaning. So now after that, you multiply by the derivative of this. This is what I was telling you. Whenever you are multiplying by chain rule, if you have for example u to the power x, just multiply x there to u, then subtract x by 1, then find the derivative of u. So du dx, that's those simple. So we now need to multiply by the derivative of cos x, which is just going to be negative sine x. So du dx is going to be equal to, because this is negative and this is negative, we can say 2 cos x multiplied by this, are going to have 2 and start with sine x, then plus, cos 2x there. So after looking at the question, you can see you have in the numerator there sine 2x. So I can think of writing this as sine 2x, because from where we started with trigonometry, you can remember that sine 2x was just an identity for 2 sine x cos x. That means this our du dx is just going to be equal to sine 2x, because this is equal to sine 2x. Sine 2x. So we need to make now dx the subject of the formula, so you can cross multiply. You are going to have dx, then sine 2x is equal to du. You can multiply by sine 2x, then by sine 2x. Okay, So this and this are going to cancel out. You're going to have dx, which is just going to be equal to du over sine 2x. So after we just have the value of u and the value for dx, then we are free now to actually convert. Okay, just actually to replace. So we're going to have the integral. I'm going first to forget about this, but don't forget that since we are using u substitution, we need to change these limits in terms of u. So I'm going to say the integral now becomes 9 sine 2x. Now where there is this, we replace by u, because that's what we have been told and that's what we were using. While there is dx, we are going to put this value, which is du over sine 2x, of which sine 2x and sine 2x are going to cancel. The integral becomes 9 over u, then du, which is making a lot of sense. You can factor out 9, we don't need it. It is a constant, so we're going to have 1 over u, then du. How do we differentiate 1 over u? Something we've been doing, so we're going to have 9 ln u. Okay, so after that, we shouldn't forget that we have these values for x. So we're going to find, we know that u is equal to the simplified one we were using for minus cos x then squared. What is going to be the value of u at x is equal to pi over 2? Because you know by now that pi over 2 is no other than 90 degrees. You can convert that into Lagrange. So we're going to have what will be the value of u. So the value of u is going to be equal to 4 minus cos 90 there. Here we put cos 90 squared. We know that cos 90 is 0, so 0 squared is just going to be 0. So at this value, x is u is just going to be equal to 4. Okay, so this has now been changed to 4. Then we can now actually check the value for u at x is equal to 0. So we can say u is going to be equal to, we have 4 minus cos 0 degree. So cos 0 is just 1. You know this. So it is 4 minus 1. It is just going to give us 3. So this now becomes 3. So that means what they want you to do, they just need you to actually now put this. We can put this. Let me try to ignore. So I'm going to ignore actually I'm going to ignore this 9 because it's a constant. I'm going to put the brackets here and put on top we have 4 and down we have 3. Okay, so what can we do here? We can just replace now. I think I can do here. This is just the final answer we are looking for. We've done everything. So we have 9. Then we have ln u in those variables. So we are going to say, where there is u, you put ln 3. Sorry, it's ln 4. We start with the upper one, then we are subtracting by the lower, which is ln 3. If you can remember what we did in semester 1, you can remember that when you have ln A minus ln B, our answer when you are subtracting logarithms, you are going to have ln then A over B. If you are subtracting, if you are adding, we used to multiply. So this can also be written as 9 then ln 4/3. So that's how you go about these questions. So we've covered almost everything which you need to know about integration. It's one that we only answered the one question on application, but we are going to provide more. So this is just a call to register for tuition so that we may revise together as you are about to close soon. You know, most of you are complaining about your CA, which is just less than maybe even 10. But this can't decide your final exams, your final results. So if we just prepare smartly, you can make things very, very easy for you. You can pass. So we are doing a promotion, which is the only promotion which you can't just even try to miss, because we are going to do revision in everything, starting from test that you wrote stream 1 and stream 2 in all courses. I say in all courses until you write your exam, and all the courses are just going at 100 kwacha. That means to say each course is just 25 kwacha, but you don't need to pay in units. You just have to pay the total of 100 kwacha and be able to revise with us until you write. So I've got physics, starting from where you started with Hooke's law up to electrical energy and capacitance. We have chemistry, starting from chemical kinetics. So you understand those topics that usually come in an exam all the way up to organic chemistry. I know most of you started, so it's a must. There are some questions which will come on organic chemistry. Then we have biology. Some of you started with the DNA replication and you hand all the way up to genetics. Then if it is in mathematics, you know, mathematics is a must. We started with trigonometry. And you have a lot of complicated topics in semester 2, all the way up to integration, and I've been emphasizing on integration. Study more on integration because there will be a lot of questions which will come here. And we also have, which course am I missing here? I think I've talked about trig, DNA, chemical kinetics. That means just physics I mentioned, starting from Hooke's law all the way up to electrical energy and capacitances. So all these we are doing the revision, but our main focus will first start with exam questions. Those tests that you wrote, we get done with them. So because there is a possibility that some questions are going to be repeated, but because they are not going to repeat everything, that's why I need to go back to revise those concepts that were not aired in class, or maybe even when I was teaching you missed some concept. It's a time to revise back everything. So just inbox me on this number. I think most of you have my number, so you can just inbox me, WhatsApp me, so that you just register now, so that you'll be able to access all the lessons, because this was just a bonus lesson that I gave you for most of you who wanted to know how the revision is being done. So thank you for watching, guys. See you in the next lesson as you register. So don't forget to register and share this video to your friends.